In this video, we're going to look at how to visually summarize a quantitative variable in R. So to start with, there are three different files that you're going to want to make sure you have. There's the Module 6 R script, and so that's going to have all the example code for this video. You're going to want to have the data set that you created in Module 5 that contains just the data for your state. Now if you want to follow along with the video, in Module 5 we also created a data set that just had the data for Kentucky, so you could also follow along using that data set. And then as always, anytime that we're working with the BRFSS data, you're going to want to make sure that you have the code book handy as well. Alright, so the very first thing I'm going to do is I'm going to read in the data set that I created in Module 5. So remember, when we do this, the very first thing we need to do is set our working directory. So there's a couple of different ways that we could do this. One is we could click on the Files tab, click on the three horizontal dots. Remember, this is going to open up all of the folders on your computer. It will not show the files, just the folders. And so you could navigate to the folder where you have the work, or you have the data file that you're going to read in. So on my computer, this is where it's located. Once you open that folder, the files will show down here. So it's always a good idea to kind of go through and look and make sure that you see the file that you want to read in. So I'm going to read in the Kentucky 2020 data, so I can see that that's in here. And then next we want to set the working directory, so we can do that by clicking More, Set as Working Directory, and the code will populate down here. Now, so that you don't have to go through those steps later, so maybe you start working on the assignment now and you come back to it later, you can always copy this and paste it up here. And so now all we have to do is run this line of code, and that will set the working directory and tell R where the data file is located. Next, we're going to read in the data. We do this using the Read Csv function. So notice I have Read Csv, and I have the name of the file in quotations. To the left here, this is what I'm going to name the data set in R. And so this is what's called an object. And so once I read it in, anytime that I want to reference or call the data, this will be what I call. So we can run that line of code. Now notice after we run it, you should see your data set populate up here, so everything looks good. Now you may want to do a check of your data to make sure it looks okay. You could use the View function. That will pull your data up in a new window, and you can kind of scroll through and just glance to make sure everything looks okay. Now, as a reminder, don't forget that this data set contains all of the variables, 279, that go back to the BRFSS and the questions that were asked. Not all states asked all questions. So all of the states asked the core questions, but remember there are all those optional modules, and those are typically towards the end of the data set. And so we'll notice as we scroll through here, there are some variables that are all in A's. That means they're missing. Those are likely variables that Kentucky didn't ask those questions, and so you can see some more here as well. Alright, so I'm going to close that out. No need to keep it open. Next thing we're going to do is we're going to create a histogram. So similar to when we worked with bar charts, the first thing I'm going to do is identify a variable that I want to look at. So I'm going to look at it stands for diabetes age 3. So let's go to the codebook and look at this variable. So pulling up the codebook here, remember if you click on Control F, or if you're on a Mac, Command F, you can bring up this little finder, and so we can search the PDF. And so I'm going to put in the name of that variable. Appears one time. And so notice this one is age when told had diabetes. So how old were you when you were told you had diabetes? So let's look at the values that this variable can take. Notice that this variable can take values 1 through 97, 98, and 99. If it takes the value 1 through 97, this represents the age in years at which they were told they had diabetes. And one thing to notice here is 97 really represents 97 and older. So if someone were 101, they would be coded as a 97. If the value is a 98, it was a don't know, not sure, and if it was a 99, it was refused. So notice this is really a quantitative variable, but there are a couple values that represent categories. So really the values 97, 98, and 99 all represent categories. So before we can actually visualize this as a quantitative variable, we're going to need to remove those categories. And you'll find that there are several quantitative variables in the BRFSS that you're going to have to do this for. All right. So first thing we're going to do is, again, we're going to pull that variable from the data set. So notice here I've got the data set name, $, name of the variable, and I'm going to set that to be equal to the object dAge var. So in other words, the diabetes age variable. So running this, we can see that that is now located in R, so we can work directly with the dAge var. So the name that you choose here, you just want to choose something that makes sense for the variable that you pull. You can make this anything you want. Alright, now that we've set this, this is going to be the object that we work with. So the very first thing I'm going to do is just make a table of this object. Now we saw that the table function could be used for categorical variables. We typically don't want to use the table to summarize quantitative variables, but we can use it to kind of get an idea of the values that this variable takes. So running this, here's our table. So along the top row, what we have are the different ages that are located in the data set. And the second row is the counts for all of those ages. So for example, there was one person who was told at age 4 when they first had diabetes. There was 10 people at age 38 that were first told they had diabetes. Alright, so a couple things to notice here if we look at the end of the data set. First of all, notice there are no 97s, so I don't have to worry about removing those for the Kentucky data set. But there are 33 98s and 1 99. And remember, these represent categories, so we want to remove these before we actually summarize this variable. So the next thing I want to do is I want to figure out, okay, well, how many observations are in this variable? And so we can do this by using the length. Okay, so I see there's 2,869, which is what I expect because there's 2,869 observations. Now, one thing to keep in mind is when we find the length of a variable, that is also going to count the missing values. So our next thing is we want to figure out how many missing values there are. So we can do that just like we did with the categorical variable. And then if we actually want to call the number that are missing, so notice here I created this object dAge missing, I can look over here and see that there are 2,408 missing observations. And so this really highlights why it's so important to comment on how many missing observations you have. Because in total there were 2,869 observations, but here 2,408 of them are missing. In other words, we actually only had about 400 responses to this survey question. And if we think about what this survey question is asking, that makes sense. You know, the survey question is asking what was the age you were first told you had diabetes. So people that do not have diabetes, they're not going to answer this survey question. There's no need for them to, so they're going to get skipped. And so this is only going to be asked of those that have diabetes. So the next thing we want to do is just figure out how many are non-missing. Also note here, one thing that you can do is after you figure out the number of missing, you can always type in a comment so you've got that number for later. So I've typed in the 2,408 here. So now to find the number of non-missing observations, we're going to take the total length of the variable, which we calculated up here, and subtract off the number of missing. So notice here we have a total of 461 responses. Now those responses do include those those don't know, not sure's, and those refusals. So the next thing we want to do is remove those values that represent categories. So in other words, the 98s and 99s. And we're going to do this just like we did in the last module. So I'm going to define something that holds the values that I want to remove. So in this case, 98, 99. And now one extra thing that we need to do with the quantitative variables is we need to go ahead and remove the missing values as well. So that's why I've included the NA here. So that's going to be important when we make the histograms. And then we need to find the location where those values are located within the variable. So again, pretty much the same code that you saw last module. These next two lines are actually going to remove those responses, so don't forget there is a negative sign here. And so notice dAgeVar2, that's going to be the second version of the variable, and this version of the variable is going to have all the 98s, 99s, and the missings removed. And so notice if we look at the length of this new variable, it is now 427 observations. So remember, if we looked at the non-missing, we had 461. We had 33 98s and 199. Well, if you take 34 away from 461, you'll be left with the 427. So the last thing here, now that we have prepped our data, now we can actually create the histogram. Now, the most basic histogram you can make is just using the hist function. So I'm going to call hist and then the name of that new variable that has the 98s and 99s removed. And so here's that histogram. And this histogram is fine, and you could go in and change the color and the axis labels, the title, but the problem is the hist function by default includes the frequencies here. And we know that we would much prefer to have the percentages or the relative frequencies there. So the easiest way to do that is to use what is called the histogram function. Now, the histogram function is part of what is called the lattice library. So when you initially install R on your computer, it comes with all of these functions that we've been using, and that is what is called base R. Well, it ends up there are lots and lots of packages and other functions that you can use, but you have to call them in before using them. And so we're going to use one of those functions here. So the very first thing we need to do is actually install the lattice package, and you only have to do that one time. So let me show you how to do that. You're going to go up to Tools, click on Install Packages, and then you're going to search for Lattice, and then click Install. It will automatically populate the code down below, and then after it's installed, you have to call Library Lattice. And this one you will have to do each time, not within a single R session, but like if you work on this for a little bit, you close R, save your file, and come back, you'd have to run the library again. So let's run that. Okay, so now this is ready to go. If you get this warning message, don't worry about that. And now we can create our histogram. So let's run it. And here's what it looks like. So that's a nice looking histogram. So let's talk a little bit about what I changed or added in here. So the first thing is you're going to have your title, Age when told had diabetes, and remember we always want to include our sample size here. The X lab here is going to be age. The color, I've used steel blue here. Again, lots and lots of colors that you can use in R. And then the last important one is breaks 9, and this will be the one that you'll want to play with. For each of your variables, you're going to want to pick a number of breaks that make sense for the variable that you have. And so what the breaks are determining is how many bars you have. So a breaks equal to 9 here, that ends up with having bars that are width 10. And for age, that makes pretty good sense. Now for example, let's move this up to 18. So notice if I doubled that, now I have breaks of, bar widths of 5, which would also make sense for age. Now let's make this really big. Let's make this 50. This is way too small bin width. So what you're going to find with histograms is you want to kind of find a nice middle ground. You don't want your bar widths to be super tiny, but you also don't want them to be super big. And playing with the breaks will help that. And so for example, I could change this to 3, and we see that we end up with 4 bars of age width 20. So that one's not that informative either. So what width you use for your bars is really going to depend on the variable that you're working with. So for age, a width of 5 to 10 makes sense. If you were working with another variable, that bin width might not make sense. And so you just kind of have to play with it based on what your variable is. And there's not necessarily one right answer for all histograms. Again, you want some nice middle ground. You don't want super wide bars, but you also don't want super narrow bars either.